Hello students, in this lecture series we will discuss about electrophilic substitution reactions of aniline. In aniline, lone pair of electrons present on nitrogen atom, they involved in resonance. The resonance structures of aniline are as follows. This is structure of aniline. The lone pair of electrons present on nitrogen, they involved in resonance. They are in conjugation with the alternate double bonds present in the benzene ring. Hence, we can write resonance structures now. Movement of electron takes place like this. Then, like this is also called a resonance structure or canonical structure number 1. This is canonical structure number 2. Movement of electron takes place like this. Negative charge forms a bond, and this bonded pair of electrons, they concentrate in the para position. You are going to get third structure. This is structure number 3. Now movement of electron takes place like this. You are going to get next structure. This is structure number 4. Next movement of electron takes place like this. Then this double bond red pair of electrons, they move towards this nitrogen. You are going to get structure number 5, resonance structure number 5. Structure number 1, 2, 3, 4, 5. These are the canonical structures or resonance structures of aniline. Here we can see that in ortho and para position, there is slight increase in the negative charge. Electron density is more, that can be represented like by writing delta minus. Incoming electrophile attacks these positions only. This is about the resonance structures of aniline. Now let us see the next part. Aniline is more reactive than benzene. Aniline is more reactive than benzene. Now let us see. Aniline is more reactive towards electrophilic substitution reaction if you compare with that of benzene. From these resonance structures of aniline, it is clear that NH2 group donates pair of electrons to the benzene ring. Here in aniline, NH2 group donates pair of electrons this aniline, this NH2 group donates pair of electrons to the benzene ring. Hence, electron density increases in the ortho as well as para position. This attracts electrophile more strongly towards this benzene ring. Hence, aniline is more reactive. Aniline is more reactive than benzene towards electrophilic substitution reactions. Since NH2 group increases the activity of benzene ring towards electrophilic substitution reaction, it is said to be an activating group. NH2 group is activating group. Now let us see why aniline use ortho para substitution product. It does not give meta substitution product. Generally it gives ortho and para substitution products. In the resonance structure of aniline, a negative charge is present on ortho as well as para position, as it is shown in this structure. Here also ortho position and para positions are rich in electron, or negative charge is present at the ortho and para positions, and it is not found in the meta positions in any of these structures. Hence, electrophile prefer to attack or prefer to add or attack to the ortho and para positions. Hence, aniline gives ortho and para substitution product. Therefore, NH2 group is called ortho and para directing group. By donating pair of electrons to the benzene ring, this NH2 group of aniline increases electron density in ortho as well as para position. Therefore, this NH2 group is called ortho and para directing group. Now we will discuss bromination of aniline. Aniline reacts with bromine water at room temperature to give a white precipitate of 2,4,6 tribromo aniline. Aniline reacts with bromine water at room temperature. It gives 2. This is position number 1, 2, 3, 4, 5 and 6. 2, 4, 6 tri bromo aniline. This is a white precipitate. As NH2 is donates electron to this benzene ring, electron density is more in the ortho as well as para position. Hence, we are going to get tribromo derivative, tribromo aniline. If you want to get only monobromo aniline, we have to deactivate this NH2 group. That process is called as masking. Deactivate the deactivate the NH2 group so that we can get only monobromo product. The activating nature of this NH2 group can be reduced by acetylating aniline. Acetylated aniline is less reactive towards electrophilic substitution reaction. Hence, it always gives para substituted product. This on hydrolysis gives para substituted aniline as major product. Now let us see the example. Aniline, when treated with acetic anhydride in the presence of pyridine as a catalyst, gives acetanilide, which is then treated with bromine in acetic acid, treated with bromine in CH3COH, gives parabromoacetanilide as a major product. The product formed is then hydrolyzed in the presence of acid. Hydrolysis either in the presence of acid or base to give parabromoaniline. This is Br and here NH2, parabromoaniline. By deactivating this NH2 group, we can get only mono-substituted or monobromobenzene in this case. This is the bromination of aniline. Now we'll discuss nitration reaction of aniline. When aniline is treated with concentrated nitric acid and concentrated sulfuric acid, this is also known as nitrating mixture. Aniline gets protonated to form anilinium ion, which is meta-directing. Therefore, in addition to the ortho and para derivative, meta derivative of aniline is also formed. Now we'll write that this reaction. Aniline reacts with concentrated nitric acid and concentrated sulfuric acid at 288 Kelvin of temperature. It gives 51% para product, para nitroaniline, 47% meta nitroaniline, and 2% orthonitroaniline. So you are going to get dairy products. As here we are going to get a mixture of products. If you protect this NH2 group by protecting this NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled and the para-nitro derivative can be obtained as major product. Aniline, when subjected to acetylation in the presence of pyridine catalyst, gives acetanilide, which on nitration with nitrating mixture at 288 Kelvin gives para-nitroacetylide as a major product, which on hydrolysis gives para-nitroaniline. This is how we can prepare only one type of nitro compound, nitroaniline, by protecting the NH2 group by acetylation. Now we'll discuss sulfonation reactions of aniline. Aniline reacts with concentrated sulfuric acid. Aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate, which on heating with concentrated sulfuric acid produces para aminobenzene sulfonic acid as a major product, which is commonly known as sulfanilic acid. I'll write this reaction. Aniline reacts with concentrated sulfuric acid. Aniline reacts with concentrated sulfuric acid, gives anilinium hydrogen sulfate, NH3 plus HSO4 minus anilinium hydrogen sulfate. Which is heated to 453 to 473 Kelvin in the presence of concentrated sulfuric acid, produces sulfanilic acid, that is para-aminobenzene sulfonic acid, NH2 SO3H. This is sulfanilic acid. Aniline reacts with sulfuric acid to form anilinium hydrogen sulfate, which on heating with concentrated sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid. It is generally known as sulfanilic acid. This is the sulfonation reaction. Now, this sulfanilic acid form contains both basic amino group and acidic sulfanilic acid group. Hence, internal salt formation takes place, forming Zwitter ion. Here we are going to get Zwitter ion. This NH2, this is sulfanilic acid, SO3H, sulfanilic acid, NH3 plus, SO3 minus. This is Zwitter ion. NH2 is basic in nature, SO3 is acidic in nature. Acids are those which donates proton, so it donates a proton to this basic group, so NH2 becomes NH3 plus, SO3H becomes SO3 minus. This contains both positive and negative charges within the molecule. Such type of compounds are called as Zwitter ion. Such type of compounds are called as Zwitter ion. This is about sulfonation of aniline. Aniline does not undergo Friedel-Crafts reaction, that is Friedel-Crafts alkylation or acylation, because aluminum chloride, which is used as catalyst for Friedel-Crafts reaction, acts as Lewis base. Anhydrous aluminum chloride, AlCl3, it acts as Lewis base. Lewis acid acts as Lewis acid. Anhydrous aluminum chloride, which is used as catalyst in Friedel-Crafts reaction, acts as Lewis acid, reacts with aniline. In turn, it reacts with aniline. The lone pair of electrons on nitrogen, atom of this aniline are donated to aluminum chloride, resulting the formation of salt. Due to this nitrogen of amine, aniline acquires positive charge. And hence acts as deactivating group. Hence, it does not give Friedel-Crafts reaction. Anhydrous aluminum chloride, which acts as Lewis acid, reacts with aniline. The lone pair of electrons of this nitrogen atom of aniline are donated to aluminum chloride, resulting in the formation of salt. Due to this, nitrogen of aniline acquires a positive charge and hence acts as strong deactivating group for further reaction. Hence, it does not answer. Hence, it does not give Friedel-Crafts reaction.